This is demonstration number 16, part 1. Using the data plot view, it flies a complete flight illustrating the pitch transition rules shown in demonstrations 9 through 14. Initially, we are at 3,000 feet and 250 knots, with a pitch attitude of 2 degrees and EPR setting of 1.04. We will enter a 200 knot climb, which will require a pitch attitude of 8 degrees and an EPR setting of 1.36. Both the pitch attitude and EPR setting will be set together because this is a changing both flight path and airspeed situation. Notice that the airspeed will stabilize at 200 knots. We will now make a precise level off at 15,000 feet. Using the appropriate lead, we will rotate to the zero rate pitch attitude of 4 degrees to capture 15,000 feet. We will maintain climb EPR in order to accelerate. Now that the altitude is captured, we must coordinate a pitch attitude decrease with increasing airspeed in order to maintain a constant altitude. As we approach 250 knots, we'll have to set the EPR to 1.09 in order to maintain a constant airspeed. Now we will accelerate to 340 knots. We first set the EPR to 1.30, and since this is a constant flight path maneuver, we will coordinate pitch attitude changes with airspeed changes. As we approach our target airspeed of 340 knots, we'll set the EPR to 1.12 in order to maintain a constant speed. Now we will decelerate to 300 knots. We first set the EPR to 1.05 and then coordinate a pitch increase with decreasing speed. Approaching 300 knots will increase the EPR to 1.11 to maintain 300. Now we will enter a 1,000 foot per minute descent, maintaining the speed at 300 knots. Since this is a constant speed maneuver, we will coordinate pitch changes with power changes. We now set minus 0.6 degrees and EPR 1.01. Notice that the airspeed remains at 300 knots while the flight path stabilizes at 1,000 feet a minute. Next, we will level off at 13,000 feet at the same 300 knots. And again, since this is a constant airspeed maneuver, we will coordinate pitch changes with power changes. We will use the experimentally determined altitude lead of 17 feet. We will now enter a 240 knot idle descent. Since we are changing both flight path and airspeed together, we will set pitch attitude and power together. We now set the pitch attitude of 0.5 degrees and idle thrust. Notice that the target airspeed of 240 knots and the target vertical speed of 1,000 feet a minute are approached at the same time. After making a slight pitch change due to altitude effects, we will now level off at 7,000 feet. In this case, we will level off and slow down to 210 knots. So using a 24-foot altitude lead, we'll rotate to 2.6 degrees to capture 7,000 feet. As the altitude is captured, we must increase pitch attitude with decreasing airspeed in order to maintain altitude. And as we approach our target speed of 210 knots, we'll set the EPR to 1.05 in order to maintain the airspeed constant. Since these pitch transition rules are based on the laws of physics, unwanted errors will occur if they are not followed. This is demonstration number 16, part 2. Using the flight deck view, it flies a complete flight illustrating the pitch transition rules shown in demonstrations 9 through 14. We will now enter a climb, setting both pitch attitude and power at the same time. The airspeed is gradually decreasing toward its target value of 200 knots. Now, maintaining 200 knots, we will level off using a precise transition at 15,000 feet. Plotting speed has now been slowed down. Rotating to the zero rate pitch attitude, we capture 15,000 feet. And maintaining climb EPR, we now accelerate toward our target speed of 250 knots, maintaining 15,000. Approaching 250 knots, we'll set the EPR to maintain that speed. Next, we will accelerate to 340 knots. The first step is to set the EPR value to 1.30. And since this is a changing airspeed constant flight path maneuver, we must coordinate pitch changes with airspeed changes. Notice a decrease in pitch attitude as airspeed increases. As we approach 340 knots, we will have to reset the EPR to the value that will maintain it. Next, we will slow down to 300 knots. First, we set the EPR to 1.05 to initiate the speed change. And in order to maintain 15,000 feet, we will increase the pitch attitude as the airspeed decreases. And approaching 300 knots, we will increase the EPR setting. The airspeed now remains constant at 300 knots. Next, we will enter a 300 knot, 1,000 foot per minute descent. Since this is a constant airspeed maneuver, we must coordinate pitch changes with power changes. Notice the pitch and power change occurred together. The airspeed remains at 300 knots and the flight path is stable at 1,000 feet per minute. The next transition will be similar. We will level off at 13,000 feet, maintaining 300 knots. And since this is a constant airspeed transition, we will coordinate pitch changes with power changes using an appropriate altitude lead. Notice that the altitude is immediately captured and the airspeed remains at 300 knots. We will next begin a descent to 240 knots and a vertical speed of 1,000 feet per minute. Since both flight path and airspeed are changing together, we will set both pitch attitude and power simultaneously. We now set the new pitch attitude of 0.5 and the power setting to the idle thrust value. Notice that the airspeed is decreasing and the vertical speed is also heading toward its target value. Both 240 knots and 1,000 feet a minute will be reached at approximately the same time. We will next level off at 7,000 feet and simultaneously slow down to 210 knots. Using an appropriate lead, we will rotate to the zero rate pitch attitude to capture the altitude. Now that the altitude has been captured, we must coordinate a pitch increase with decreasing airspeed in order to maintain the altitude constant. And as the airspeed approaches 210 knots, we will reset the EPIR to the value that will maintain the speed constant at 210.